Okay, so I just wanted to come back and finish these last couple of solving equations from our lesson. Now, if you tried this number 2, oh, I was supposed to make my list over here. Um, Another part of our list, which I just added here, was factor. And I am going to factor this one, number 4. And the first way that I factor is I take out the greatest common factor. And if you notice, there's a cosine in each of those. So I'm going to take out a cosine. So I'm going to take out cosine x, and I'm going to leave inside whatever's left. So that's 2 cosine x minus root 3 equals to 0. So this is like the backwards of distributing, right? So if I distributed this right now, cosine x times 2 cosine x is 2 cosine squared. And cosine x times negative root 3 is negative root 3 cosine x. So this is fine. So this is like you taking out the greatest common factor before you start factoring. And from here, because it's something times something, I can use the zero product property rule and separate them, right? So I get cosine of x equals to 0, and I get 2 cosine x minus root 3 equals to 0. And so what I'm going to do here is I'm going to solve each of these independently. Okay, on the left-hand side, some of you recognize cosine of x being 0 here and here because it's, oh, not here and here. Sorry, I got that backwards. Cosine of x being 0 here and here because they're asking where is x 0, right? When do you not move left and right? So x here is going to be pi over 2 plus, plus pi, plus 2 pi k, and 3 pi over 2 plus 2 pi k. Now, if you want to condense that all together, so you don't have to write all of that, you can also alternatively write just, or you could just write 2 pi over 2 plus or minus 2 pi, not 2 pi k, sorry, plus pi k n. Sorry, plus pi k. Now, why just plus pi k, Ms. Johnson? Where did the 2 pi go? Well, if you look at the top, you're going around to a whole 2 pi, but at pi, you hit a solution. So this basically is saying at every pi, you're hitting a solution. So follow me, right? Here's a solution, plus pi, 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 here's a solution. Every pi, you're getting to another solution. So that's why it's pi k. Okay. So which one do you like better? I like pi k just because it's shorter. But if you don't recognize that, it's not wrong. Okay. Okay. So I'm going to scoot my work over here. So that I can actually do some work. All right, so there's my other equation. And so now I'm going to go, okay, so one of my tools was to use SADMEP to isolate it. So I'm going to isolate this by adding root 3 and dividing by 2. So then I would get cosine x equals to root 3 over 2. If I did too many steps on that, just pause it, add the root 3, divide by 2. And then so some of you again are like, oh, Ms. Johnson, that's my 30, 60, 90 triangle exactly. So again, I don't really use cosine inverse if I don't have to. Cosine is going to be root 3. So this is root 3 and this is 2. So this is 1. So this is pi over 6. So x is pi over 6. Right? Plus again my 2 pi k. And where's my second solution? Where else is cosine positive? Cosine is also positive on the fourth quadrant. So it's going to look like that. So my answer is 11 pi over 6. So that's or 11 pi over 6 plus 2 pi k. So here's my answer. So when you're doing these problems, your job is to find the answer, find out where else cosine is positive, like in this case, and then add a bunch of circles to it. Okay. Okay, so for this one, I'm going to try my different strategies. The problem with SAD mapping number 5 right now is that I have 2 signs, so I can't SAD map there. And therefore I can't use trig inverse because it's not isolated yet. I can't factor it. Now some of you are like, but Miss Johnson, I see 2 signs. Yes, but one sign is taking the sign of 2x and the other sign is taking the sign of x. Therefore, I can't factor it out like I did the previous one because I'm not factoring out the same thing. It's not a greatest common factor. So then my next tactic is identity. And some of you already recognize this identity. You see the double angle sine 2x. So the double angle formula looks like this. Sine 2 theta equals 2 sine cosine. So I'm going to be using that identity. So I'm going to just write it here so everybody knows. Here's my identity. Sine 2 theta equals to 2 sine cosine. Right? This is my identity that I'm going to use just so that you know where I'm coming from. Okay, so that means I'm going to take all of this instead of this part. But that 2 in front there is still there. So I'm going to leave that 2 there. I'm going to put a big old parentheses here. And then I'm going to put minus 3 sine x equals to 0. And then I'm going to plug that into here. Okay, so that in there gets 2 sine x. Okay, so some of you are asking, okay, Miss Johnson, why is it not 2 sine 2x cosine 2x? Because that's what's happening in here, right? The 2 theta, because when we're using this identity, it goes from 2 theta to theta. So just make sure that you're comfortable with that. So I'm going to multiply out here. So I get 4 sine x cosine x minus 3 sine x equals to 0. And then I'm going to start using it again. I'm going to go through my SAD map, factoring. And some of you are like, oh, Miss Johnson, now you have sine x and sine x. Now you can factor out a sine x. Exactly. So I'm going to factor out a sine x. And I'm left with 4 sine, not 4 sine x, sorry. 4 cosine x minus 3 equals to 0. And then now I can use my zero product property, where here I go sine x equals to 0 and 4 cosine x minus 3 equals to 0. So sine x equals to 0. Some of you are saying, oh, Miss Johnson, it's 0 and pi. So I'll write x is equal to, this is going to, see if this makes sense to you, pi k. So 0 pi would be 0. So 0. And then it hits it at every single pi. So that's why it's just pi k. If you want to write your answers as x is equal to 0 plus 2 pi k, and then pi plus 2 pi k, that is fine. But I want you to be able to see that there's a way to condense those answers. Okay. It takes a while for students to understand it. So don't feel frustrated if it doesn't make sense. Okay, so same thing goes here. I'm going to SAD map here. I get cosine x equals to 3/4. I do not recognize this triangle at all. So then I'm going to use my calculator. So that's going to give me, let's see, cosine inverse of 3/4. So I get 0.7227. So x equals, or is about, I forgot it already, 7,227. So that guy is this, something like that. And you also have to ask yourself, where else is cosine, right? Right? So then I have to say, okay, it's down here too. So this is going to be plus 2 pi k. And then I'm going to go with sticking my 2 pi minus in front of that. And I get 5.560. 5.560. I'll just go with 5.560 plus 2 pi k. And you can do minus 2. I always forget minus. Okay, so that is how you do this. So I'm running through these relatively quickly because the whole point is you're just, again, adding up all these things together, right? You are, all of these things individually here, all of my tools that I have listed here, those aren't new tools. SADMAP, you've been knowing since, and using probably since 6th and 7th grade. Trig inverse, that is new, but it's not new to this section. Factoring is, again, not new, but it is new to this section because we are now factoring equations with sine and cosine in it. Identities is not new. We've been using those identities, but now we're using them to solve equations. So there's nothing necessarily new that we're doing. We're just taking a bunch of stuff that we already know how to do and incorporating them together. Okay. So it's kind of like a mashup if you think about it. All right, my last problem for today is going to be this one. Now, this one, students tend to do this one wrong because they want to distribute that squared, and you can't do that. Okay, you can prove it to yourself in many different ways using a calculator, but you cannot just square everything. That's not the way it works. So what I will show you is I will actually square it out. So I'm going to square this out by using the box method because that's what I'm used to. And it's going to look funny, but that's okay. So this is sine x, cosine x, and this is sine x, cosine x. So this is sine squared x, right? Remember that sine x squared, like this, when you go like this, sine x quantity squared is equal to sine squared x. It's just a faster way to write it. It's a convention. Sine x times cosine x is sine x cosine x. There's no, can't do anything. Same thing goes here, sine x cosine x. Some of you are like, ooh, I wonder if that's going to be that one identity. Good job. Okay, so I have total here sine squared x plus 2 sine x cosine x plus cosine squared x. Oops, that's not what I wanted to write. Equals to 3/2. Now, some of you are noticing a couple of different identities. Okay, some of you are noticing this the double identity here, and some of you are noticing your Pythagorean identity here. So very good. I'm going to write both of those identities over here just so you know what I'm using. So don't forget that sine squared x plus cosine squared x equals 1. And the double angle formula is sine 2 theta equals to 2 sine theta cosine theta. And some of these, because I've used them so many times, I've memorized them. And so it's really fast for me to recognize them. If you're still getting comfortable with them, whenever you get stuck, your job is to go to the identity sheet and look if you have anything that matches. Okay, and in this case, this matched in like 2 different parts. So this right here turns into sine of 2x. And then these two things over here is plus 1 equals to 3/2. And then so now, if you look, I'm going to go back to my tools and I'm going to try to SAD map. Okay, so here's me SAD mapping. I'm going to subtract 1. So I get sine of 2x equals to, if I take 3/2 and I subtract 1, that's going to be 1/2, right? 1.5 minus 1 is half. So some of you, again, are recognizing this and you're like, I know this triangle. And I'm like, I know. So sine of 1/2 is opposite over hypotenuse. And so when you do that, that looks like this, 1 over 2. And you recognize that this is my 30, 60, 90 triangle. Specifically, this is pi over 6. So this guy is pi over 6. So 2x equals to pi over 6 plus 2 pi, right? And then the famous question, where else is sine positive? Sine is also positive here in this quadrant because of all students. So what guy is this guy? That's 5 pi over 6. So then I get 2x equals to 5 pi over 6 plus 2 pi. And then I'm going to just divide out by 2 from everybody. So let me just do that. Let's see. I'll use this color. So divide by 2, 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 divide by 2. So here goes my answer. Okay. So this is going to go here. This is x is equal to pi over 12 plus pi k. Oops, I forgot my k's over here, guys. And then this guy is going to be, or 5 pi over 12 plus pi k. So did you see how those 2's divide out? That's what I was seeing. So there goes my answers. I can check every single one by using the graphing calculator and plugging one side in sine x plus cosine x quantity squared on for one line, and then see where that intersects to 3/2 on the other line, and like find out all those intersections. I could do that. What I really want you to be comfortable with is like using this list, right? Try to SADMAP it. Try to get that inverse trig. And so here, if you're not using the inverse trig, if you notice I probably only used it once, this is also using your 30, 60, 90, or your 45, 45, 90 triangle. And keep asking that question, where else is cosine positive? So when you're doing these types of problems, you want to use these strategies because that's how you get from being stuck. Okay. So thank you so much for listening. Have a great day.